Hey there, Ravens. Welcome to Atomic Theory. Today we're going to talk about Dalton's atomic model. Sir John Dalton, was the first to develop a comprehensive atomic theory that he based on experimentation and data collected. Four tenets of his theory, his four basic assumptions that still hold true today. All matter is made of tiny indivisible particles that he called atoms. Atoms of the same element are identical. Those of different elements are different. Atoms of different elements combine in whole number ratios to form compounds. This is called the law of definite proportions, and in a couple slides I'll talk more about that. Also, Dalton said that chemical reactions involve the rearrangement of atoms. No new atoms are created or destroyed, and that's the beginning. He was the first to get talking about the law of conservation of mass and matter. Okay, so what did his model look like? His atomic model, his belief was that atoms were solid spheres with no parts in common. So each element had a completely different type of atom, and it was solid and nothing in common with another one. So carbon was a solid sphere with no parts in common to, say, nitrogen. Okay? All right. So now let's talk law of definite proportions. Each compound has a specific ratio of elements. He did his ratio by mass. Water is always 8 grams of oxygen for each gram of hydrogen. So hopefully you're thinking right now, and you're saying to yourself, no, there is not 8 times more oxygen than there is hydrogen because water's formula is H2O. He's doing this by mass. Oxygen has an atomic mass of 16. Hydrogen has an atomic mass of 1. Okay, so you're getting 8 grams of oxygen to 1 gram of hydrogen. Later, scientists would show that this ratio, this law of definite proportions, was true, but it was really whole numbers of atoms. And that's where we get the 2 hydrogen atoms to the 1 oxygen atom. Okay, and that is the end of part 1. Hooray! See you in a few minutes for part 2.